right, everybody. I hope you're as excited as I am to talk about logic today, because I think today, moving forward, is where the content of this course, starts to get a little bit more interesting. So, as you can see, what we're talking about today are truth functions. Now, a truth function is a compound proposition whose truth value is solely determined by the truth value of its components. Now, it's important to clarify that the only truth values that we're dealing with are true and false. Makes sense, right? So what's a compound proposition, right? Well, say we have something like not A, right? The truth value of not A is solely determined by the truth value of A. So if A is true, right, and then we negate that, not A, so not true is false, right? But what if A were false? When we negate that, okay, so not false, now not A is true. So as you can see, not A is solely determined by the truth value of A, right? And likewise, if we have phrases like A or B, right? That's going to be determined by the truth values of A and B, right? What if we have A and B, right? What if we have something for every main operator we've looked at? The truth value of these are all going to be determined by the truth values of A and B respectively. And we're going to create truth tables for these, as you can see, so that way we can see when these statements will be true and when they will be false. But let's not get ahead of ourselves. We still got to talk about statement variables. Now, what are statement variables? We use statement variables, which will be lowercase letters. Most often you'll see you'll see P, Q, R, S, and then if you need more, you can obviously use more. We'll try to stay away from X, Y, and Z because we're going to use that way later. But for now, we use statement variables, which can stand for any statement. So what do I mean by that? I mean, I can have a variable, just like we do in math, right? When we say X is equal to something, and X is a variable we can manipulate, we could say P, right? P could just be equal to A, right? It could be very simple, right? Or maybe P is a little more complex. Maybe it stands for the whole statement, A or B, all right? Maybe P stands for the statement A, if A, then B and C. So as you can see, these statement variables can stand for any kind of statement, as complicated or as simple as you would like it to be. Now, let's talk about truth tables. Truth tables are pretty cool, right? And I know I say that about a lot of things that might not be cool, but this is cool. Because now we're going to define our 5 main operators with their truth values. So how do we make a truth table, right? Okay, well, here's what we want to do. We want to use one of our statement variables, right? So let's use P, for example. And we want to let's look at not P first. We want to look at not P. Now, the size of our truth table is determined by the amount of statement variables we're using. Since we're only using one statement variable, it can only take on the values true or false. So the size of this table will be too long, right? So we'll have P can be true or false. And so when P is true, not P is false. When P is false, not P is true, right? And we talked about this out loud. I didn't write out the table before, but we said this out loud. And so this would be a truth table for the negation operator for our tilde, right? And so let's just do an example to make some sense of this, right? Let's switch up the flow, right? Let's use some pink colors. Let's say I have a channel, right? I have a YouTube channel. I'm not writing YouTube out. That is a true statement, right? Let's say that this is equal to H, right? So H is our statement, and now we can use our statement variable P to stand for H. So P is the statement I have a channel, right? And that's true. Otherwise, we're living in a paradox. So that's true. But then if I said not P, right? So I don't have a channel, that's false. That's false. Now what if I have a false statement, right? I am speaking Italian. I am speaking Italian, and I'm going to just skip the part where I make that, like, a capital letter for a statement. So, like, I'm going to skip the part where I would call this capital S and then rename it to a variable P, right? I'm going to just skip that and go straight to the variable, right? So let's say the variable P is I am speaking Italian. That is a false statement, right? So not P is going to be true. If I say I am not speaking Italian, or it is not true that I'm speaking Italian, in whatever way I choose to negate the sentence, that negation becomes true because the original statement was false. I probably over-explained that. You probably didn't need all that, but it never hurts to have examples, because guess what? We got 4 more main operators, so we got 4 more examples incoming, I think. All right. Now what I want to talk about here, and let's just clarify, right? This is for negation. What do I want to talk about now? I want to talk about and first, so we'll do our dot, and then we're going to go on to our wedge. Now, with and, we're going to have more than one statement variable. We will have 2 statement variables. So we'll use P and Q. We want P, we want Q, we want P and Q. And now, please bear with me. I'm going to say some math. Don't get scared. Remember before how I said the length of our truth table would be too long because we had one variable which could be true or false? Now we have 2 variables which can both be true or false, right? So this is a basic counting property where if we have, let's say in this case we have 2 variables with two choices for their values, we multiply the possibilities, so their values, to see how long this table will be, right? So since there's 2 choices for P and 2 choices for Q, 2 times 2 is 4, our table will be 4 long. If we had 3 variables, it would be 8 long. If we had 4, it would be 16 long, and so on. I just want to throw that in there. So what possible combinations of truth values can we have? Well, we could have true and true, we could have true and false, we could have false and true, and we could have false and false. And we need to look at all of these cases. So, in the case that both P and Q are true, then the expression P and Q is true. If one of P or Q is false, then the entire expression P and Q is automatically false. And then if both of them are false, then the entire expression itself is false. Now let's look at an example in English to represent this, right? So here's what I'm going to say. If I had this, if I said I bought oranges, and I bought apples, right? That is my expression, right? And we might say that this is O and A, orange and apples, right? And then we'll just use our statement variables, P and Q. Now, if I bought oranges, so my claim is I bought oranges and I bought apples, right? So I come home and look what I have. I bought some oranges, I bought some apples. So P and Q are both true. So obviously my entire expression was true, right? I wasn't lying to you. I went out, I bought some oranges, and I bought apples. Now, let's say I bought oranges, but I didn't buy apples. Then you would obviously say that my original statement, I bought oranges and apples, is false because I didn't. I did not buy apples. And the same were to be true if I bought apples, but I didn't buy oranges. You'd be like, no, your original claim is false. And of course, if I claim that I bought oranges and I bought apples, but I didn't buy either of those, then you are obviously going to call me a liar and say that the expression, I bought oranges and I bought apples, is false because I bought neither. Now we're going to look at our wedge, and we're going to use the exact same example. So, just scroll down a little bit so we can still see that sentence. So we're going to use our wedge. We're going to have P. We're going to have Q. We're going to have P or Q. All right, and now we're going to do true and true, true and false, false and true, and false and false. Now let's make our table a little bit bigger. Now, when both P and Q are true, then P or Q is true. When one of P and Q are true, then the statement P or Q will be true. And if both are false, then the entire statement P or Q will be false. Again, let's look at our example, right? So let's just write out the sentence again. Let's say I bought oranges. I bought oranges. And I bought apples. And I bought apples. There we go. And then we're going to say A and O. And then we'll just call this P and Q. Now, of course, My claim, oh, sorry, this should not be and, this should be or. I bought oranges or I bought apples. Now, if both are true, I did buy oranges and I bought apples, then the entire sentence, I bought oranges or I bought apples, is true. Remember when we said or is inclusive way back when? Like, I don't know, maybe last video or 2 videos ago, those are our only options. The whole statement, P or Q, will be true if both of them are true, right? It doesn't need to be one or the other, it can be both. And then obviously, if one or the other were true, then the whole statement would be true, right? If I claim to you, hey, I bought oranges or I bought apples, and then you see that I only bought oranges, I was telling you the truth. I said I bought what? I bought oranges or I bought apples. If I only bought apples but no oranges, still true, right? I bought oranges or I bought apples. The only case where P or Q is false is when both P and Q are false. So if I claim I bought oranges or I bought apples, and then I bought neither of them, my original statement, P or Q, is false, right? Hopefully that makes sense. I say right as if I'm... Sorry that you could see that whole bar right there. I say right as if I'm like waiting for a response that I cannot hear. Alright, anyway, let's move on to our horseshoe. Let us move on to our horseshoe. Okay, so horseshoe, we're going to have P, we shall have Q, and then we shall have if P, then Q, right? And then same thing, true, 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 false, false, true, false, false. Now this is definitely going to take an example, I think. I feel like there's no way that this just makes sense. So if I have if true, then true, that is a true statement. If I have if true, then false, that's a false statement, right? And now here's where things get tricky. If I have if false, then true, that is true. And if I have if false, then false, that is also true. Now this is a little weird. That's why we're going to do an example, right? So my claim is going to be, let's switch up our colors again to pink, just to be consistent. If you pass the test, then you will pass the class. All right. If I pass the test, if you pass the test, then you'll pass the class, right? And then we're going to just say, I don't know, if P, then P. No, that's not going to work. We'll say if P, then C. I don't know, you pass the class. And then we'll go back to our little statement variables. Remember, these are lowercase, so P, then Q. Now, if you pass the test, then you'll pass the class. That is, I'm your teacher, and that is my claim to you, the student, right? And say it's true that you passed the test, and it's true that you passed the class. Then, my promise to you, if you pass the test, then you'll pass the class, must be true. So when P and Q are true, P then Q is true. That should make sense. Now, if you pass the test, right, but then you don't pass the class, then you would call me a liar, right? Because I claim that if you pass the test, you would pass the class. Yet here you are passing the test and not passing the class. So you would say P then Q is false when P is true and Q is false. And that should also make sense. But now let's look at the two times where P is false. So, you don't pass the test, but you still pass the class. Would you call me a liar from my original claim, if you pass the test, then you'll pass the class? I mean, I guess we could debate that, but you really shouldn't, right? Because you didn't pass the test, but you'll pass the class. I never said that that wasn't a possibility. I'm strictly talking about the cases where if you do pass the test, right? But you didn't even make that requirement. You failed the test, but you passed the class. So you wouldn't necessarily call me a liar in this situation, right? So when P is false and Q is true, P then Q will also be true. And likewise, if you fail the test and then you fail the class, you still wouldn't call me a liar, right? I'm only claiming that if you pass it, then if you pass the test, then you'll pass the class. That is the only thing I'm claiming, right? But you failed the test, right? So how could you call me a liar for something where you didn't even meet that requirement, right? So if P is false and Q is false, then P then Q is also true. We call this vacuously true, right? So remember with our conditionals, right? Okay, let's just go back to white. We have an antecedent, I think that's what we called it, and a consequent. If I don't think it was called antecedent. I'm sorry if that is not the right term, but let's just say it is. Um, Whenever the antecedent is false, the entire statement is just vacuously true, right? We don't even care what Q is. P then Q will just automatically be true if P is false. Okay? And so now, if I'm sorry if that's a little confusing, it's all right. It makes sense over time. Now we're going to go to our last logical operator, the biconditional material equivalence. So we're going to have P, Q, P if and only if Q. And then, just a little heads up, once I'm done doing this truth table, we'll just do some example problems. They're pretty cool. You want to stay around for this. I wouldn't lie to you and tell you that they're cool when they're not. Okay, we are making our truth table. There we go. All right, now remember, P if and only if Q. P if and only if Q, right? That's just shorthand for saying if P then Q and if Q then P, right? Because it's P if Q and only if Q. Like, you get it? P if and only if Q? Get it? Okay, just wanted to put that out there so that way we can make some sense of this. And now let us look at an example sentence. So here's what I'm going to say. You will pass the test. A lot of talk about passing tests today. If you have a test in your life right now, I hope you pass it. You will pass the test if and only if you study. That's a bold claim. So I know there's a lot of us that don't study and still pass, but let's just pretend this is true. So you will pass the test, just say P, if and only if you study, let's say S, right? And then let's use our statement variables, lowercase p, if and only if lowercase q. Now, if it's the case that, and I kind of skipped a step here, I didn't fill out the entire truth table. When P and Q are true, P if and only if Q is true. When P and Q are opposite truth values, P if and only if Q is false. And when they're the same, it's always true, right? Because let's look at the case where they're both true. So I passed the test and I studied, right? Then the original claim that you will pass if and only if you study was true. I did not lie to you. Now, let's look at the case where one is true and one is false. So you passed the test, but you did not study. You would call me a liar then, right? Because I claim that you'll pass the test if and only if you study. Yet here you are passing the test without studying. You just disproved me. My original statement is false. And likewise, say that you failed the test, but you studied. I said that you would pass the test if and only if you study, right? So if you studied, you should be passing. Yet here you are studying and failing the test. So you would call me a liar. So my original claim, P if and only if Q, is false. Now, if you don't pass the test and you didn't study, you'd be like, oh, Mr. Johnny, he was telling the truth. He said, I'll pass the test if and only if I study. And I failed the test because I did not study. So he was telling the truth. So when we have the biconditional, P if and only if Q, that entire statement will be true when the truth values of P and Q are the same. It will be false when they differ. Okay, so now that we have all these truth values, all these truth tables written out. Oh, and by the way, if you're not just here for fun, I know there's a lot of people coming to my channel because, they're just so passionate about learning for fun. But if it's the case that you're not here and you're using this as like a supplement to a class, you really should memorize every single one of these truth tables. Especially if you have like timed tests, you need to memorize these truth tables. Otherwise, you are not finishing that test on time. I memorized these in my class, and that did not help at all. Like, I would be working on my test until the very last second. It was rough. Anyway, personal story aside, let's do some example problems. Here's what I want to do. I want to say, what do I want to say? I want to say, let A, B, C, P, and Q all be statements, right? So these could be whatever they are in English, but I don't really care what they are. They're just letters to me. So let them all be statements, right? let A and B be true, let C be false, and let the truth value of P and Q be unknown. Now, what I'm going to ask you to do is determine the truth value of the following statements. And I'm going to write out 5. And we're going to go through this, and it's going to be super cool. So please stay with me. And also, please try them on your own. Okay, what color does everybody want? Okay, I heard somebody say purplish pink, so that's what we're going to do. All right, so we have 5 things we're going to look at. We're going to look at A or P. We are going to look at Q and A. We are going to look at if A, that's a 3. If A, then P. We're going to look at, this is a little bit more complicated. If P, then A. If and only if Q, then B. It's a lot of ifs and only ifs. And then at 5, we're going to look at not. Here, that's not how we write it. We look at not Q and C. If and only if not Q or A. Wow, okay. So, we want to determine the truth value of these statements, right? Now, the first thing we got to do is work towards the main operator. Remember we spoke about main operators, right? That it was important. We did it for a reason. Here are our main operators, and we're going to work towards them, right? So here's kind of how you'd go through these problems. It gets very cluttered on your page because we're writing a lot of T's and F's, but it's important that we do this. So the value of A is true, right? And here, actually, let's not do white so this doesn't get mixed up. We'll go green. Let's say A is true, and then P, what is P? P is unknown. We don't know what P is, but remember from our truth table, right? Let's go back and look up here. That's why I didn't erase these. P or Q is true every time at least one of the components is true. So it's only false if both components are false, right? So although we don't know the truth value of P, we know that A is true, which means the entire statement A or P will be true. Now, let's look at Q and A. So, we don't know what the value of Q is, right? But we know that A is true. Well, it turns out that that's not enough information to determine this truth value, remember? Because let's look at our dot. P and Q is true only when P and Q are both true. If one of them are false, then the entire statement is false. So we know that A is true, but we don't know what Q is. And the entire statement Q and A, its truth value is depending on what Q is. So since we don't know what Q is, we're just going to cross that out and say unknown, right? Or we could say, I don't know, that's not how you spell unknown. It's impossible to determine, right? And explain why. All right, if A, then P. So A is, what is A? A is true. And P is, we don't know what P is. Okay, is that a problem? It is a problem, right? Because remember here, I'll just go back instead of making you remember. With our conditional, or in our case, A can be true, right? But the entire statement A then P is reliant on the truth value of P. Because as you can see, if we have, so let's get that out of here. If we have true, then we have true. If we have true, then false, we have false. And since we don't know the value of P, we don't know the value of this statement. Oh my gosh, I'm so sorry for all that today. So this is also going to be unknown. Now let's look, okay, and I promise these last two, we will be able to figure them out. So if P then A, if and only if Q then B. All right, let's look at if P then A. So we know that A is true and P is unknown. If we look at our conditionals, right, it actually doesn't matter what P is, right? So if A is true, then P could be false or true because then P then A will always be true. So this right here is going to be a true statement if P then A is true. Now Q then B. Q we don't know, but we know that B is true. So for the same reasoning, if Q, then B is also going to be true. And true if and only if true is a true statement, right? Because we have the same truth values. If it was false if and only if false, that would also be true. But anyway, we have true if and only if true. That's a true statement. So the entire statement is true, and we're able to determine it with all we know and all we don't know. Now we've got not, Q and C, if and only if not Q or A. Okay, let's look at this. So Q and C. We don't know what Q is, right? But we know what C is. So C is false. So automatically, knowing the truth table for a conjunction, it doesn't matter what Q is. Since C is false, Q and C will be false. But we have not false, right? So that is going to be true. All right, now let's look at not Q or A. Again, Q is unknown, but A we know is true. A is true. So it doesn't matter what Q is. Since A is true, the entire phrase Q or A will be true. But we have not true, right? So not makes that false. And if we have true, so we have true if and only if false, that is a false statement. It cannot have opposite truth values on either end of a biconditional. So true if and only if false is false. And that's it for our examples. I hope you found that as exhilarating and cool as I did. Yeah, that's all we have for today. We're gonna continue this. We're gonna continue to do some more cool stuff with logic. We are barely scraping the tip of the iceberg. But anyway, if you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.